4. Condense. Increase information density. The goal here is to use small yet easily recognizable objects to convey more information per page. IBCS asks us to maximize space efficiency through smart layouts and compact design elements. More information per page means fewer pages, faster reading, and less time wasted. First is use small components. Practically, this means use small fonts and small objects. Chart elements don't need to be enormous to be legible. Use small elements. Icons, indicators, labels can all be compact without losing meaning. Maximize space using narrow page margins and reduce empty space. White space has aesthetic value, but empty space where information could live is a missed opportunity. One well-designed dense page is better than 3 sparse ones. Add data. Add data points and dimensions. More data on the same chart, when done well, is more informative, not more confusing. Effective data visualization enhances insight by adding context directly into charts and tables. Embed explanations to show not just what happened, but why. Placing short notes directly on charts removes the need for cross-referencing. Extend charts by adding benchmarks or targets, turning simple data into meaningful evaluation. Use multi-tiered charts to combine values and variances in one view, showing performance and context together. Overlay charts combine different measures using bars and lines, revealing relationships instantly. Embed chart elements in tables by adding visual cues like color bars, enabling quick pattern recognition while keeping precise numbers. Small multiples, the same chart type repeated for different segments, all at the same scale, are one of the most powerful techniques in data visualization. Up to 25 per page is possible. Multi-charts, ratio trees, and chart table combinations are other techniques for packing meaningful relationships into a single view. The discipline is, every element must add unique information. If it doesn't, remove it. Rule 5. Check. Ensure visual integrity. This rule is about honesty. Information should be presented in the most truthful and most easily understood way possible. The pitfalls IBCS warns us against are manipulated axes and elements, misleading representations, improper scales, and distorted data adjustments. Every one of these mistakes can make your data say something it doesn't actually mean, and whether intentional or not, that erodes trust. Manipulated axes and elements. 5 ways that charts can mislead. Truncated axes that exaggerate differences, clipped elements that hide data, logarithmic axes that compress dramatic change, inconsistent class sizes that make comparisons invalid, and scaling problems that can be solved honestly with the right technique. Being able to spot these patterns and avoid producing them is a fundamental skill for anyone who builds or presents data. Misleading representations. Area and volume comparisons. When comparing quantities visually, linear representations are almost always more honest than area or volume. Misleading maps. Using colored areas where the size of the area has nothing to do with the value being shown. Use correct area comparisons, prefer linear ones. Charts communicate by encoding data into visual lengths, heights, and areas. When the scale is wrong, or when different charts in the same report use different scales for the same unit, the visual message stops matching the numerical truth. Size charts to given data. When a dashboard contains multiple charts representing the same measure, each chart should be sized proportionally to its data range, not stretched or squeezed to fill available page space. Use identical scale for the same unit. Here, millions of USD, readers naturally compare them visually. And use scaling indicators if necessary.
A scaling indicator solves this. A clearly marked zoom element shows the smaller measure at an expanded scale, while preserving a visual link to the true scale relationship. Distorted data adjustments. Inflation and currency movements are real economic effects that change the apparent value of the numbers in your reports. The question is not whether to account for them, you should, but whether you make those adjustments visible to the reader or silently bake them into the numbers. Rule 6. Simplify. Avoid clutter. Remove complexity. Cut redundancy. Reduce distraction. Skip decoration. These 4 principles cover everything from slide layouts to chart typography. The discipline of simplification is about respecting your reader's attention. Every element in your report that doesn't serve the message is competing with the elements that do. Avoid unnecessary components. IBCS tells us unnecessary components forces eye to filter noise before finding data, slows comprehension. Avoid cluttered layouts. A chart with a thick border, a colored background, and 1 bar is cluttered, but data poor. Avoid animation and transition effects. They're distracting and add no information value. Avoid colored or filled backgrounds. They reduce contrast and make text harder to read. Avoid unnecessary components. Avoid decorative fonts. Use clean, functional typefaces. Your font should be invisible. The content should do the work. Avoid decorative colors. Color should encode meaning, not create visual noise. Avoid frames, shading, and pseudo 3D effects. These are the ghosts of 1990s PowerPoint. They're gone for good reason. Replace with cleaner layout. More simplification rules worth highlighting. Replace grid lines and value axes with direct data labels. If you can label a bar directly, you don't need an axis and grid lines taking up space. Avoid vertical lines. Right aligning data in tables eliminates the need for most vertical dividers. Avoid redundancies. Avoid repeated words. If every row in a table contains the word revenue, put it in the header once. Obvious terms are not neutral. They make the reader's eye work slightly harder to find the actual information buried among them. Superfluous words often enter charts because the author is trying to be thorough or professional. But thoroughness is measured by the quality of the information, not the quantity of the words. Fewer words, clearly chosen, communicate more than many words that dilute each other. Avoid distracting details. Redundancies are words that shouldn't be there at all. Distracting details are different. They are real data, accurately presented, that nonetheless pull the reader's eye away from what matters. When everything is labeled, nothing is emphasized. The chart is giving you data without guiding you to the insight. A number displayed to 6 decimal places demands more precision than any business decision requires. If your unit is already thousands or millions, 1 decimal place is almost always sufficient. If your unit is individual currency, round to the nearest whole number. If a segment or bar is too small for a label to sit clearly within it or immediately adjacent to it without overlapping anything, do not label it. They create clutter without adding meaningful information.
And the final rule, Rule 7, express. Choose proper visualization. Choosing the right visualization is not aesthetic, it's analytical. The wrong chart type can actively mislead, even with perfectly accurate data. IBCS gives us clear guidance on when to use which chart types and, just as importantly, which chart types to avoid. Tables versus charts. The first decision is always chart or table. Charts are biased. That's not a criticism, it's their purpose. But choose your chart type based on the message you're trying to convey, not on what looks impressive. Charts are inherently interpretive. They highlight patterns and convey messages. Use them when you want to show a trend, comparison, or deviation from expectation.
Tables have high information density. They're precise, honest, and neutral. Use them when your audience needs to look up exact values or when multiple measures need to be compared across many dimensions. Chart types. IBCS recommends specific chart types for specific purposes. Choosing the right chart type is one of the most fundamental decisions in data communication. The wrong type doesn't just look incorrect, it can make an accurate dataset tell the wrong story entirely. On the left side of this slide is a reference matrix. It maps 8 chart categories, from accumulation charts to waterfall charts, across 3 data contexts: time series data points, time series patterns, and structural comparisons. Use this matrix as a decision tool. First, identify what kind of data you have and what you want to show, then read across to find the appropriate chart format. The right side of the slide shows 9 real examples, each labeled by type. Let's start with column charts. These are the workhorses of time series reporting. They're best when individual data points need to be read precisely. Use stacked columns when the part-to-whole relationship is as important as the total trend. The scattergram on the left plots each item in the product portfolio by 2 dimensions. 3 colors separate the product categories. At a glance, you can see whether service items cluster at higher margins, whether parts are high volume but lower margin, and which individual items are outliers in either direction. The line chart in the center tracks 2 share prices over 7 months. The technique to notice here is selective labeling. Not every data point has a number. Only the meaningful inflection points do. The labels anchor the reader to the values that matter most. The bubble chart on the right is a growth share matrix. Each bubble is a business unit. Its horizontal position tells you market growth. Its vertical position tells you relative market share. And its size tells you net sales. 3 variables, 1 chart. Waterfall charts are the specialist tool for contribution analysis. They answer one type of question that no other chart type handles well. How did we get from here to there? The calculation waterfall on the left tracks a balance over time. The horizontal variance waterfall in the center does the same thing for a year-to-date variance. The vertical variance waterfall on the right does the same decomposition but across markets rather than across time. The choice between horizontal and vertical orientation is about what you're decomposing. If you're decomposing across time periods, use horizontal columns. If you're decomposing across structural categories like markets or segments, use horizontal bars in a vertical layout. These are your primary tools. Master them. Table types. Tables are the format of choice when precision matters more than shape. Where a chart communicates a trend or relationship visually, a table communicates exact values for every dimension simultaneously. But not all tables are the same. A well-structured table is designed as deliberately as a well-designed chart. The rows, columns, headers, and hierarchy all carry meaning. A poorly structured table forces the reader to do interpretive work that the format should be doing for them. This slide shows 11 table components and formats, the basic structural components that every table contains, variance tables, hierarchical layouts, and cross tables. Every table is built from the same fundamental components. Understanding each one separately makes it much easier to design tables that work. The time series table in the top left is the foundational example. Entities in rows, time periods in columns. You read across a row to see one country's history. You read down a column to compare all countries in 1 year. This bidirectional readability is what makes the time series table so widely used in management reporting. The variance table extends the basic scenario table by adding 4 calculated columns: the absolute variance versus prior year, delta PY, the percentage variance versus prior year, delta PY%, the absolute variance versus plan, delta PL, and the percentage variance versus plan, delta PL%. These 4 columns answer the 2 standard management questions simultaneously. How did we do versus last year, and how did we do versus plan? The cross table is the most complex format. Both the rows and the columns carry independent categorical dimensions, countries and account levels in this example. Every cell is an intersection. The value at the cell for Germany and AL3 is the net sales for Germany in that account category. This format is appropriate when the reader genuinely needs to navigate 2 independent dimensions simultaneously. It is not appropriate as a default layout. It should be reserved for situations where the intersection data is the point. The row header column is the leftmost column, the one that names what each row is about, like Austria, Belgium, France. It must be visually distinct from the data. Measure columns carry the numbers. Scenario columns are specifically the columns carrying those scenario values. Hierarchical columns appear when a table has 2 or more levels of column grouping. In the P&L statement shown here, the top level groups columns by year, 2019, 2020. The second level shows the quarterly breakdown within each year, Q1, Q2, Q3, Q4, plus the annual total. Hierarchical rows appear in the right example. Countries are grouped within continents or regions, and regions roll up to a world total. Each level of the hierarchy is visually distinguished. Region-level rows are bold or shaded. Country rows are lighter and indented. This structure is essential for any structural decomposition where sub-entities belong to a parent entity, business units within divisions, products within categories, markets within regions. The column header row is the row at the top of a table that labels each column. It is the row the reader reads first, and it sets their expectations for everything below it. Measure rows are rows within a table body that carry calculated summary values. A structure row is a non-data row used to label or group a set of data rows below it. Charts to avoid. This list might surprise some of you. Speedometers and gauges, they take up enormous space to show one number. Spaghetti charts, more than 3 or 4 intersecting lines become unreadable. Use small multiples instead. Pie charts, they only allow one-dimensional analysis and rarely convey meaningful insight. A bar chart almost always communicates the same information more clearly. Area charts without purpose, they contain little information per unit of space used or can be misleading. The question to ask about any chart is, does this convey the message more clearly than the alternatives? If not, choose differently. Replace inappropriate representations. Prefer quantitative representations over text slides in presentations. The principle here is whenever your data has measurable values, amounts, proportions, rankings, variances, use a quantitative representation. A presentation slide should support what you are saying, not reproduce it in written form. If the slide contains everything you intend to say, the audience will read the slide and stop listening to you. Always add scenarios and variances. Showing actual data without a plan or prior year comparison removes the context that makes the data meaningful. Showing what happened is necessary. Explaining why it happened is what makes data useful for decisions. Show interrelations. Ratio trees, structured hierarchies, and scatter plots reveal how variables relate to each other. This is where analysis becomes insight. Show the components behind a calculated result using a tree structure so the reader understands not just the outcome, but the formula that produced it. Use aligned rankings and connector lines to reveal the relationship between 2 attributes of the same entities, and apply cluster analysis to large data sets to surface the natural structure that averages and flat charts cannot show. So there you have it, the success formula. Say your message clearly, unify your notation, condense your content, check your integrity, express with the right visuals, simplify by removing everything that doesn't serve the message, and structure it all logically.